So in this video, I'd like to tell you about the law of refraction. And of course, this is what we are sort of calling our bending law, right? Because what it refers to is if you have a surface like this and you have a normal drawn right here, then as a light ray goes in, the question is, what is it going to do as it hits this surface right here? Well, it's going to bend like that. Okay, and there's some trends that we need to discuss, but this is sort of the basis here. Let me show you some actual bending. So here is a image here that I like to do in class, but of course we can't at the moment. It's a person holding a laser pointer, and maybe you have one. You can even do this experiment at home if you wanted to. Just get a laser pointer and shine it into a cup or jar of water, and you can see here sort of that the laser beam is going in this direction right here. It goes in like this, and there's where it hits the interface between what's up here. Well, this is air right here. This is water right here. And it bends. See the bending right in there. See, the light just is definitely not traveling along this original direction here at all. It just isn't doing that because it encounters, so it's not doing that. And it's not doing that because it encounters this air-water boundary or interface. So in the previous videos when I was drawing a line here to indicate some material like this, that's what I was talking about. And right there where it hits that material, it bends. And this bending law has a lot of bizarre consequences because of this law of refraction, the way it bends. And the reason why it has these bizarre consequences is this follows here. Let me try to draw you something here. If your eyeball sort of looks like this here, say there's your eyeball, and maybe let me put some eyelashes on or that kind of thing. When your eye receives light into it like that, that allows you to see, your brain always assumes that the light came from something straight away. In other words, your brain doesn't know that light bends. It always assumes it came from straight behind it. And so when you have some refraction going on, like say there was the light that say came up in here and maybe hit some material and bent into your eye like that, your eye is going to think this ray didn't originate over here where it actually did. It's going to think it originated back here. So it's going to think that the light ray actually came from here, and that really can cause a lot of really weird optical illusions. So again, your brain doesn't know about light bending. So if there was some reason that the light bent right here to go into your eye is going to interpret this as light coming from back where it came from. So it's going to think that whatever this thing is right here that you're looking at, whatever that thing is right there that generated the light ray, your eye is going to think it's there. There's a lot of weird examples of this. Let me show you a couple. Here's probably the most famous one. Again, this is something you can very easily do at home right in front of you. Just get a glass of water and put a straw in it and look at it from the side, and it'll look like the straw is all busted up. But of course the straw isn't busted up. It's just, again, the action happens right here at this air-water interface. It just bends like that, and this game that it plays on your brain is exactly this thing that I tried to show you here. There's some bending at the interface, so it sort of makes one part of the straw look like it came from another part like that. So you see all that weird thing, weird effects. I think you've probably seen that before. This was kind of funny. I saw this at a pool house once here, but it says refraction bending, and it says no glassware allowed in the pool area. And of course, it's just a safety sign, and they have the examples of the glassware. And look, they even put the bending of the light on the straw there on this sign. So I thought that was kind of clever, Ha 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 ha. You get my point? Yeah. All right. Anyway, onwards. Here's sort of a duck that you might see in a sort of an aquarium at a zoo or something. Again, the poor duck is not all cut up. Just law of refraction. Again, you always see these things right here at that boundary again. So what do we have up here? Well, here's a bunch of air. Here's a bunch of water, and the refraction just happens there. Refraction, not reflection. I saw this one on the internet recently. Someone in a clear pool, looks like his head is clearly over here, but just again, I hate to sound like the broken record, but this stuff always happens right here at the boundary. What do we have here? We have some air and we have some water. So it's something like this. Here comes a light ray in, boom, hits and bends like that relative to the normal right there. Polar bear in the zoo, same kind of thing. Then of course you have the party refraction distortion. Saw this somewhere too. So boom, 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 boom. Everyone's upper body is displaced relative to their lower body. Of course not really, just a law of refraction. Anyway, Okay, so there's some details about the law of refraction that we have to look at now in terms of getting into astronomy and understanding some astronomy things. We'll look at that in the next video.